All right, this one is kind of a mess, right? This is kind of a tricky one. Um, so n plus sine squared n over n cubed plus 1. All right, so I'm first of all going to take a look at this and make a guess. And now the key here is that I know sine squared is always between 0 and 1. So sine squared n is always between 0 and 1. Now sine is between plus and minus 1, but when you square it, the sine squared is always between 0 and 1. Okay, so I know that's, that's I can probably say that this is at most looks like n plus 1, right? The numerator at most looks like n plus 1. So if I've got something that looks like n plus 1 over n cubed plus 1, those plus 1s are really going to be negligible once n gets big. So it's going to start looking like 1 over n squared, which I know converges. So I probably want to compare this to something that, a p-series, 1 over n squared, which I know converges. So let's see if we can do that. All right, so this whole thing is positive. So 0 less than or equal to n plus sine n square, or sine squared of n over n cubed plus 1. Okay, so that's the a sub n of the series I'm interested in. And I'm going to say that that is always less than n plus 1 over n cubed plus 1. All right. And so I can actually then divide this up, and I can divide each term in the numerator by n cubed plus 1. So this is really the same thing as n over n cubed plus 1 plus 1 over n cubed plus 1. And then I can actually look at two different series. So, and I know that this is less than 1 over n squared, right? That's, the first term is less than 1 over n squared, because it's basically, as n gets bigger and bigger, this looks more like n over n cubed, which is just 1 over n squared, right? So this plus 1 in the denominator is just making it slightly bigger, which makes a slightly smaller number. And so I know 1 over n squared is bigger than this first term. And then the other terms, 1 over n cubed, is less than 1 over n cubed plus 1 is less than n 1 over n cubed. So now I know that the series, if I have this series, n equals 1 to infinity, is equal to 1 over n squared plus 1 over n cubed, right? Now I can actually write that as two series, right? That both converge. So I have 1 over n squared plus the summation n equals 1 to infinity 1 over n cubed, right? These are both p-series, and they both converge. So since this converges, and I've said that it's less than the series I'm trying to test, right? Then the series I'm trying to test, the series, I'll just call it the series, that I'm testing, converges by the direct comparison. Direct comparison test. Okay, so my conclusion is that it converges. Okay, so so that's all the examples I have, and I've got I actually summarized our findings here in this little table for you. So hopefully that will help you when you're going through the homework. You can refer back to this table to find all the different methods that we have at our disposal currently for testing whether a series converges or diverges. And in the next lecture, I'm going to add a couple of more, so I'll update this table. But this is sufficient to do to do the discussion questions for today. So I will see you in class.